Morning students, Sairam, this is Megha Miss here, and today we are going to do our revision part 1 of our lesson number 4, that is effects of electric current. Okay students, so we will proceed. So the part which you studied was a definition for the electric current. Yes students, what is electric current? An electric current is the flow of electrons through a conductor. You need a conductor, right, which will allow this passage of electrons. Quantitatively, current is defined as the charge passing through a conductor in unit time. So you will remember the definition, that is current is defined as the charge passing through a conductor in unit time. Okay, then the next part which you studied, that was the energy transfer in an electric circuit. Now what is this normal electric circuit? You have studied students in 9th standard also. Yes, many components are there in your electrical circuits. So if a charge Q flows from A to B, okay, some charge is flowing from A to B, that is Q. Okay, so work, what is work done? It will be VABQ. Okay, has been done on Q while going from A to B. Okay, so we are going to refer our chapter number 3. I told you of 9th standard you will study that. Okay, from where does the energy come to do this work? The source of energy is the cell. Okay students, what it is the source of energy? It is the cell. Okay, now the source of energy is cell, what I told you, right? The cell gives this energy through the charge Q to the resistance where work VABQ is performed. If the charge Q flows from A to B in time t, that is, the work is performed in time t, then during that time the energy VABQ is given to the resistor. So what happens to this energy? This energy is received by the resistor and is converted into heat energy. The temperature of the resistor is increased. Okay students, so what is happening student exactly? The charge Q, when it is flowing from A to B in time t, work is performed in the time t. Okay, then during that time the energy, what is the energy in the circuit? VABQ, and this energy VABQ is given to the resistor. Okay, now what happens to this energy which is given to the resistor? What will happen? This energy which is received by the resistor, it is converted into heat energy. Okay, and the temperature of the resistor is increased. Okay, so P is equal to electrical power, you have studied this in 9th standard, is equal to energy upon time required. Okay, so is equal to, what is the energy student? What it was? VABQ upon time required is T. Okay, so Q upon T, you know it is equal to I. Okay, charge upon time. Okay, that is equal to current. So I will write it as VABI. Okay, now the source of energy, the cell, gives in time t the energy P into T to the resistor. Okay, if I is the current flowing continuously through the circuit, the heat produced in the resistor in time t will be, we will write it as heat produced, means H is equal to P into T. Okay, so is equal to, now you know P value we have got VABI. Okay, first equation you can see, so we have substituted it as VABI. Just I'll show you, see here, VABI into T. Okay, now what we are going to do according to Ohm's law? What you have? V is equal to IR. Yes, this equation you have. But now here we are not taking V. We are talking in concept of VAB. Okay, so we have written VAB is equal to I into R. This is the equation 3. Okay, what you are going to get student? Equation 4. H is equal to V square AB into T upon R. Okay, you are going to get this equation, our fourth equation. Okay, H is equal to V square AB, yes, multiply by T upon R. Okay, now what we are going to find students? We have to, similarly, H is equal to, what you will get? Yes, instead you have H is equal to I into I multiply by R into T. Okay, how you got this equation 5 students? Just see here, H you have, yes, VAB into I into T. Now you know VAB value you have got, that is I into R. So I have substituted here, instead of VAB I have written I into R. Imagine one I and one R, okay, and remaining is what? I and T. So I and T is also there. So what it became, student? I square RT, okay. H is equal to I square RT, okay. So we'll proceed. I hope till here it is clear. Yes, so H is equal to I square RT is called the Joule's law of heating, okay. Unit of electrical power, P is equal to VAB into I. You have this, so volt into ampere. So 1 volt into 1 ampere is equal to 1 volt. How you can write? 1 joule upon 1 coulomb multiply by 1 coulomb upon 1 second. Okay, so if 1 coulomb gets cancelled out here, this and this part, what it is remaining? 1 joule upon 1 second, which is equal to watt. Just remember here, you don't need all these relationships. You just need here that the unit of electrical power is watt. You have to remember this as it is going to be used in the sums. Okay students, till here is it clear? Yes, so the last final statement is important for you. Thus the unit of electrical power is 1 watt, that is watt we write. Okay, W, capital W, or you can write the whole spelling WATT. Okay, now next part what you studied was the heating effect of electric current. Now what is this, students? When a resistor is connected in an electrical circuit, heat produced is due to the current. Yes, heat is produced due to the current. We saw now only. This is known as heating effect of current. Okay. Equipment such as water boiler, electric cooker, electric bulb make use of the heating effect of electric current. Electrical conductors having high resistivity are used here. For example, a coil made up of an alloy nichrome is used in the electric heater cooker as a resistor, okay, while a tungsten wire is used in the electric bulb. Because of the current, this wire is gets heated nearly to what? 3400 degrees Celsius, and it emits light. When it gets heated up, it starts emitting the light, okay. The hot wire also radiates heat to a certain extent, okay. The wire is also radiating certain amount of heat, and also it gets heated up, okay. Now these are the coil. You can see coil is there. Coil of a cooker is seen like this. Coil of a heater you can see. Coil solenoid type you can see. Okay, we have studied in this chapter what is solenoid also. Yes. Now, so several times we hear or read about a building catching fire due to short circuit. Yes, you must have heard this. Sometimes if we switch on an equipment in our house, the electrical fuse wire melts and the electric supply shuts down. Yes, this happens, okay. Let us discuss about the cause briefly. Why this happens, students? The home electrical connection consists of a live, neutral and earth wires. Okay, remember this. The live and the neutral wire have the potential difference of 220 volts. Okay, then the earth is connected to the ground. Earth wire is connected to the ground. Due to the fault in the equipment, or if the plastic coating on the live and the neutral wires gives way, the two wires come in contact with each other. Gives way means if it is removed, the plastic coating is removed, or it has become dirty and it has got removed, what will happen? These two wires will connect each other, okay, will come in contact with each other, and a large current will be flowing through this because of the heat, okay. If any inflammable material such as wood, cloth, plastic, etc. exist around that place, it can catch fire, okay. Therefore a fuse wire is used as a precautionary measure. We have learnt about fuse wire, yes, in 9th standard textbook. I told you when you will study this lesson, please go through your 9th standard textbook, okay. As soon as the high current flows in the circuit, the fuse wire melts, okay, and breaks the circuit, and avoid any mishap is avoided. So whatever any accidents or anything would happen, this is avoided because of this fuse wire, okay students. So these are the different types of the fuses which we are using at home, okay. You must have seen many of them. If you have seen if any electrician comes and he is doing any of the mishap work, then that time he is using all this, okay. So now next part you studied, that is the magnetic effect of electric current. Now what is this magnetic effect, students? We will do an experiment and see. Connect the circuit as shown in the figure 4.5. You can see the circuit is there. Yes, connect a copper wire thicker and straight as compared to the connecting wires between A and B. Okay. What? Keep a magnetic needle adjacent to the wire. You can see a red color magnetic needle also have kept. Keep the plug key open in the circuit and observe the direction of needle. Okay. Close the plug key. First you have to, the circuit is not running. So we have kept it open. But when you insert the key, what will happen? Close the plug key and observe the direction of the needle. What do you notice? So we will see what is the changes we are seeing. Now interchange the connecting wires connected to the cell and observe the direction of magnetic needle. Then what I'll do? I'll interchange the direction of the connecting wires. Do you notice any relation between the direction of current and position of the needle? We'll see. Do we see anything? Yes, magnetic effect is observed because of the current in the wire. Yes, there is a deflection in the needle. Okay, students. This means electricity and magnetism are closely related. As there is a deflection in the needle, we will say that yes, electricity and magnetism, they are closely related. Okay. Now, of course, when the direction of the current is changed, the magnetic field will also change. Okay. So, therefore, we are going to study magnetic fields and such electromagnetic effects we have seen. Okay. We have seen the electromagnetic effects. Finally, we will study the principle, construction and working of electric motor. Yes, you have studied this in this chapter, and the electric generator. Okay, students, am I clear with this? Okay, so we'll move to the next part. Next, we will see one more experiment to study the magnetic field produced around a conductor. Okay, for that, connect the circuit as shown in the figure 4.6. When a large current approximately 1 ampere or more flows through the thick copper wire passing through a cardboard. Can you see? This is my thick, you can see this is my cardboard and a thick copper wire is also there. Okay. The magnetic needle kept at different points on the cardboard around the wire stands in different directions. Make these directions in pencil. Can you see these directions? What we are getting of the magnetic fields? Yes. Okay, like in the concentric circles. You have studied this. Okay. So, we'll move. Yes. So, now instead of magnetic needles, spread iron filings. Now, I am removing the magnetic needle, and what I am going to do? I am going to spread the iron filings. What you will see, those iron filings are also arranging themselves in a concentric circles. Okay. And observe, the iron filings arrange themselves in the circular manner around the wire. Now, why does this happen, students? You have studied magnetism and magnetic field in the previous standard. Yes, we have studied. We have seen that the iron filings spread along the magnetic lines of force. What we call these lines as? We call them as magnetic lines of force. Okay, students? I hope till here it is clear. Should we proceed? Okay. So, next part you studied, that was a right hand thumb rule. Okay. Now, what is this, student, right hand thumb rule? This is a convenient rule for finding out the direction of the magnetic field produced by a current flowing through an electric conductor. Okay, so this rule will help you to tell the direction of the magnetic field which is produced by a current flowing through the conductor. Okay, imagine that you have held the conductor in your right hand. Okay, you are keeping it in your right hand in such a way that your thumb points the direction of the current. So, this is your thumb and it is pointing the direction of the current. Okay. Then turn your fingers around the conductor. You have turned your fingers, right? These are your fingers which are turned like this. So, this is going to tell you the turn fingers around the conductor is the direction of the what? Magnetic lines of force. Okay, student. So, these are your magnetic lines of force. Okay, you can see with the yellow color arrow also they are showing. Yellow color is the arrow of your turn fingers and white are your magnetic lines. Okay, and how are they? You can see they are in the concentric circles. Okay, students, remember this diagram. If you remember, you can write the right hand thumb rule on your own. Okay. Now, next part we are going to study, that is the magnetic field produced by current through a circular loop of a conducting wire. I have sent some video also in the group. I hope you have seen that. So, some of the part is clear to you. Okay. A circuit is completed by connecting various components as shown in the figure 4.8. You can see a circuit is there. Okay. Now, if a current passes through a loop of magnetic lines of force are produced at each point on the loop. Okay, loop means it is a circular loop. So at any point on that circular loop, you will get the magnetic field of lines when it is kept in the circuit and a current is flowing. Okay, as we go away from the wire, the concentric circles representing the magnetic lines of force become bigger and bigger. As you go away and away, whatever these circles will be there now, they will go bigger and bigger. Okay, as we go towards the center of the loop, and when you come towards the center of the loop, the circle becomes so big. If you come near towards this, okay, you will see that the circles are becoming towards the center. The circle arc is so big that it appears like a straight line. Okay, so I hope till it is clear. We'll proceed. So in the figure 4.8, the magnetic lines of force are shown near the points P and Q only. Can you see only P and Q? You can see magnetic lines of force, right? However, they will be created near each point on the loop. Now loop is circular loop, so at each point on the loop, you may see the magnetic lines of force. Okay, likewise each point will produce magnetic field at the center of the loop. Okay students, I hope till here it is clear to you, diagram is clear to you. Please go through the video which I have sent in the group if you have not seen it. Okay, so this is the part which we did the revision. These are all the parts for today. I'll stop it here. Next part, revision, we will see in the next presentation. Okay, please go through the diagrams, study them properly, the rules which are given, okay, that you study from this chapter, the AC generator and all. Okay, you don't have the DC one, but AC one you have, so start studying this chapter. Okay students, you have it for the exam. Okay, we'll meet in the next presentation. Thank you. Sai Ram.